We'll certainly share information from this event after with some of the presentations given the approval from the speaker themselves. So it seems like I think we have attained some critical mass of people, and I would not want to hold anyone off any longer. So once again, good morning, and ladies and gentlemen, partners and colleagues. Welcome to Renewable Energy Working Group's event on battery energy storage in Vietnam. We want to empower Vietnam clean energy transition with this webinar. My name is Tung Ho. I'm with the Actionable partners and the Clean Energy Investment Accelerator. Today, I'm honored to welcome you to our exciting event and some of the speakers. Oh, I think that I should have stopped the music a little bit, sorry. Okay, I'm good now. So once again, I'm honored to welcome you to our exciting event on the topic of energy storage with an assortment of speakers and their insights. With that, I'd like to go through some of the housekeeping before and some of the context before the presentation. Firstly, if you have any questions for us, please feel free to raise it in the Q&A box under the Zoom function. If there is any technical difficulties, our team will be contacted via the chat box. We also have live translation available now via the Zoom function, so please select your preferred language using the globe box found at the bottom right corner. For this webinar, we will be recording the entire event and sharing it on a video sharing platform right afterwards. The slides from the speakers will also be shared with their approvals for sure. So regarding the context of our webinar, if you are new to the working group, welcome. The Renewable Energy Buyers Working Group in Vietnam was launched in 2017 by the CEIA and also the VLIP2 team. Only pertaining to this event, VLIP is not present here as CEIA is the primary host. Our focus is on improving the understanding of Vietnam clean energy procurement among corporate energy user, brands, and companies, together with their supply chain partners. We also engage developers, investors, NGO to improve the understanding of market activities and challenges. CEIA, or the Clean Energy Investment Accelerator, is co-led by three organizations: the World Resources Institute, LabRI, Actionable Partners, and the National Renewable Energy Laboratory in the US, or NREL. We are supported by a funding perspective by a variety of partners, including the US government, Department of States, P4G, Tara Climate Foundations, and in some cases, corporate partners as well. And certainly in terms of activities, CEIA works on a variety of market engagement exercise using platforms such as this webinar series on clean energy topics. We also support policy design with regards to clean energy procurement, such as rooftop solar or the DPPA in the past, and now the distributed solar storage solution plus in this webinar. The provision of technical assistance and transaction support is also our focus with feasibility studies and case study sharing, which we will have plenty of today. I think taking that kind of approach forward, we want to replicate what we have done for the other solutions for the BESS market to accelerate its process in expansion and development. Firstly, we want to equip purchasers with the capacity and solutions via events like this webinar and the sharing of feasibility studies that we have conducted ourselves.
Hi, my name is Kathleen.
Yes, you unmuting yourself. Sorry for that. And also I think the outcome of discussion today will then be used to engage policymakers and the government in order to provide the kind of regulatory and also policy framework to support the market. And finally, I think given the sufficient resources that we have we seek to pilot projects that will serve as a case study for the market. And that has been CEIA approach across multiple topics, and now with battery energy storage. So I will go through certainly go through the first steps of, I think, knowledge sharing and capacity building with you today. We have a great agenda with an assortment of fantastic speakers from major energy buyers in Vietnam, and also developers and institutions for sure. Our speakers will consist of researchers, battery storage distributors, and also investors and developers that have a presence, at least in the local market and also in the regions of Asia Pacific. We hope to kickstart your interest in this topic and hopefully answer any questions that you may have. And I think before we jump right into the series of presentation ourselves, to set the context for our event today, I'd like to remind the audience of the successes and the challenges of Vietnam renewable energy journey in the past years. I think while we have seen a massive uptake in renewable energy capacity, there are still shortcomings in terms of curtailment and grid security that hinder the kind of further support for the sector, as you have seen this year and the last year in 2021. And certainly we feel that energy storage is one of the key solutions for the integration of renewable energy with its primary functions of load shifting or energy arbitrage or resiliencies for energy buyers themselves. However, I think there are still multiple barriers until we can see an effective scaling of this market, and that's why we're here today. So what are some of these barriers? I think first and foremost, there's no concurrent, but only incoming signal of upcoming regulations and guidance on BESS applications, either for utility scale or CNI. I think secondly, grid connection permitting is still an issue with some of the projects that wants to do distributed solar plus storage when they want to seek approval for EVN, mostly because there is no guidance so far. I think finally, there still needs to be more information and more, I think, regulatory framework on the kind of technical configurations that perhaps regulate the side of systems or different kind of connection standards for the local markets. So I have listed out quite a few barriers, but I think despite these policy gaps, CEIA is still seeing some pilot projects taking off across Vietnam. While that is quite far and few, I think it's worth bringing up these case studies for the market to be aware of. So with this context in mind, I would not want to keep you any longer. I'd like to begin our series of presentation from our esteemed guest speaker for today. The first presentation will come from Ms. Kathleen Kra, the researcher from the National Renewable Energy Laboratory, or NREL. Kathleen is supporting the REOP team in conducting renewable energy screening for the tool validation as well. Prior to joining NREL, I think her master focused on spatial analysis for residential fuels in Ireland, and also she supported the techno, economical, and logistic cost modeling of offshore wind operation and maintenance. So with that in mind, please give a round of virtual applause. Our first speaker of the day is Kathleen. The floor is yours. You're on mute, Kathleen.
Thanks so much, Tung. Are you able to hear me?
Yes, perfectly.
Is that a yes? Sorry.
Yes, we can hear you.
Sounds like the audio is from my computer. Thank you. Let's see. Thank you so much for having us today, and thank you for the introduction, Tung. am an engineer at the National Renewable Energy Lab, and my colleague Jonathan Morgenstein and I have been supporting an analysis of a techno-economic analysis of PV and battery at a case study Vietnam Industrial Park. Let's see. So we've been using a tool called REOPT that is developed and maintained here at the U.S. National Laboratory, the U.S. National Renewable Energy Laboratory, that evaluates distributed energy technologies for behind the meter and off-grid applications. And so this is a techno-economic model where we're modeling the technology and its costs and performance, as well as the project economics throughout the analysis period and project lifecycle. And so this particular analysis is evaluating the economics of battery energy storage in conjunction with solar photovoltaics to reduce electricity costs in a commercial or industrial sector application, increase the utilization of on-site renewable energy generation, and improve resilience of site operations to utility grid outages. So I will be talking through the analysis and the key takeaways. And the goal of this case study analysis is to evaluate battery energy storage, what we may also refer to it as BESS, in Vietnam, considering the Vietnam utility rates, and it's kind of an emerging technology within the Vietnam market. So although this analysis focuses on a particular case study site where we worked with a partner site who shared their data with us, the goal is to assess the techno-economic viability of this technology currently and kind of
của cái công nghệ này, cũng như là cân nhắc cái môi trường mà có thể là hiệu quả về mặt chi phí, cũng như là xây dựng cái phương pháp luận.
This technology in Vietnam. So when considering whether DERs will work for a particular site or application, there are a lot of different factors that come into play. So there's the local renewable energy resource, whether that's solar, wind, also fuels, biofuels, grid electricity, technology costs and incentives. So what does the technology cost upfront? What are for capital costs? What are the operations and maintenance costs? What incentives might be available for that technology? What are the site's goals? So whether that's purely cost savings, perhaps there are resilience goals and there are concerns about being able to continue operating in the case of an electric grid outage, and then clean energy goals as decarbonization is increasingly being incorporated into organizational targets and national scale targets. How can on-site distributed energy resources support those goals? What is the site paying in its business as usual operations? So for grid electricity, perhaps natural gas, other fuel consumption, how much is it consuming and what does that cost? And then the financial parameters. So this analysis is looking at the economics of these technologies throughout a project life. So look, in this particular example, looking at a 25-year or 10-year analysis, 10-year analysis of battery energy storage economics. And this slide is a little bit more in depth about how REOPT considers the 5 components shown on the previous slide. So REOPT is a time series model. So we are starting down at the bottom here. We model the electric and/or thermal loads. In this particular analysis, we're focusing on electric consumption. And so we're just modeling the hourly or sub-hourly electric load at the facility. And so for this example, we were provided with data, and I'll talk more about this particular case study in a couple slides, but modeling the electric load at the facility on an hourly or sub-hourly basis. Over on the left, we have a mix of different technology options. These are on-site generation and storage technologies, as well as some electrification options via geothermal heat pumps. This slide, again, is showing REOPT's capabilities. This particular analysis focuses on several renewable generation technologies, the electric grid, and battery storage, with the emphasis being on battery storage as an emerging technology and market in Vietnam. Across the top, we have several drivers of the analysis. So we have goals. REOPT is a life cycle cost minimization function. So we are seeking to identify the cost optimal mix of technologies, on-site technologies, and their system sizes and dispatch, so how they're being operated, to reduce the cost of electricity to the site throughout the 10-year analysis period. And so in addition to that, we can also consider clean energy goals related to renewable energy penetration and/or emissions reduction, and we can also consider the value of resilience in this optimization function. REOPT is considering technology capital costs, their incentives that might be available, financial parameters such as discount rate, inflation, electricity cost escalation rate projections. And we're also over here showing we are really looking at how the electric utility is billing the site for electric grid purchases. So not just what does it cost overall, but what does that rate look like? Or is there a time of use component to it? Does electricity cost different rates at different times? Is there a demand charge? And how are those costs projected to change over time? So REOPT is considering all of these different inputs in blue, and I'll talk more about those specific to this analysis in a couple slides. These are all the inputs into the model, and the outputs are shown over here on the right in green. So REOPT is outputting the cost optimal technology mix and system sizing, how that system would be operated. So when is the battery charging? When is the battery discharging? And then project economics. What are the upfront capital costs? What are the operating costs each year? What are the electric bill savings each year? And what is the net present value? So the present value of all of these life cycle costs throughout the 10-year analysis period. And then what are the implications for resilience goals and clean energy goals of these on-site technologies? REOPT is also able to evaluate how much these on-site technologies, such as solar and storage, can extend outage survivability. So in addition, if there's the base case of just on-site backup diesel generator with a limited fuel supply, solar and storage can extend the outage survivability or increase the probability of surviving an outage of a given duration. So for this particular case study, we are evaluating battery storage in conjunction with potential new solar photovoltaics at a case study industrial park in Vietnam. And so at this location, the industrial park hosts a bunch of tenants. They are primarily in the industrial sector. And the park purchases electricity from EVN and then that's purchased on a wholesale time of use rate. And so that means that the cost of electricity varies based on the timing that it is purchased. And then the industrial park sells this electricity to tenants while also operating the park's distribution system. The analysis focused on 2 feeders at the industrial park. The site provided us with interval data for historic or this past year's electric load. So we had an hourly profile showing the consumption in each hour throughout an entire year in order to capture the timing of load throughout each day and throughout each week and throughout the entire year's worth of different seasons. The site also provided us with projections for future load as the industrial park continues to grow its capacity. And so we evaluated solar and storage, both with its existing loads as well as its projected future loads. There are some on-site generation technologies currently at the site, and the site has plans to substantially scale up their renewable energy penetration in the future. So we are kind of considering this existing system and then also considering that decarbonization and on-site generation is a priority for the site. This slide shows an overview of the the rates that the site purchases electricity at. And so this is really important because we can see there are two different feeders. They're on slightly different rates, but very similar in terms of their structure. One is slightly more expensive than the other, and that's simply because of the voltage at which power is received. But you can see here they're fairly similar. And each facility has a peak. The cost of electricity during peak hours of the day is approximately 3 times as much as it is during the off-peak periods. This provides significant opportunity for energy arbitrage by purchasing electricity when it's inexpensive, charging up the battery, and then using that electricity that's cheaper during on-peak hours when electricity is more expensive. So we evaluated solar and storage for several different scenarios. I mentioned that we evaluated this with current existing loads as well as future load projections. We evaluated the economics of the existing business as usual case where there's no additional on-site technologies, generation or storage added to the site. We evaluated when only battery is considered, and then we evaluated additional PV as well as additional battery storage. Because there is not a huge deployment of battery storage in Vietnam at this point, there is not very much data about the cost of commercial and industrial scale battery storage in Vietnam. So we conducted a sensitivity analysis for battery costs in Vietnam using a range of prices that we selected based on price of battery in neighboring areas of the Asia Pacific region. So we have data points from 2020 and 2025 projections that were developed in 2020 for China, South Korea, and Australia. And we use these to inform our selection of a low, medium, and high price point for battery storage. And these are all-in costs. So this is not just the technology itself, but also installation, balance of system, labor, all of that. So these were our scenarios that we evaluated. And the results indicate that new solar PV could be significantly cost effective, whether or not it's tied in with the battery storage. So although the analysis is focused on battery storage, we did also obtain results about the cost effectiveness of solar PV. Battery storage, we ran those 3 different price point scenarios, and we found that battery, based on current electric rates in Vietnam and the consumption at this particular facility, battery appears to become cost effective right around the $400 per kW price point. And so this is the all-in price. There are not currently incentives available for battery storage, at least that we are aware of in Vietnam, but this would be the price after any incentives that are available. And we show how that compares to 2020 battery prices in China, South Korea, and Australia, as well as the 2025 battery cost projections that were developed in 2020. So this $400 per kW price point is within the range of numbers that we're seeing, but it's definitely on the lower end. That said, battery costs are coming down and projected to come down fairly quickly in the coming years. There have been some delays in that decrease due to supply chain challenges and the COVID pandemic. So it's not coming down quite as quickly as initially projected, but still decreasing rapidly. And where we found that where battery is cost effective, the value of combined PV plus battery is greater than the value of either individual technology on its own. So standalone PV or standalone battery. So the value of having a solar plus storage system provides more value than having either of those technologies operating on its own. My colleague loves this 2 + 2 = 5 kind of concrete way of thinking about this. And then we also considered the resilience value that these technologies could provide. So although the optimization does not consider the resilience value in its sizing and economics, these technologies can help a site continue to sustain operations in the case of a grid outage. And we find that the resilience value that these technologies provide is substantial and if resilience is a priority for a facility, it would be important to consider that value in the system sizing and project economics. This slide shows the results based on the current 2022 historical loads. So the business as usual case is just no new technologies, that just the existing loads and existing on-site generation technologies. And then we show here a scenario just evaluating new battery storage. So we're not considering PV. And here at the lower end of the costs that we evaluated, at $400 per kW, we see a 4-hour battery show up as cost effective. And this fairly large battery is able to provide about $74,000 worth of net present value. So this is the present value of life cycle cost savings throughout the 10-year analysis period relative to the business as usual case. So if the business as usual case life cycle costs are just purchasing electricity from the grid, the net present value is the savings in electricity costs minus any capital costs spent on the battery system itself. So the capital costs are being recouped and an additional $74,000 worth of savings are being provided by this system. And that is being provided by energy arbitrage. So again, buying electricity when it's inexpensive and using it when it's expensive to reduce those expensive grid purchases. At the medium and high price point, battery did not on its own show up as cost effective. When we considered new solar and battery storage, this at the lower price point for battery, we see a combined solar plus storage system showing up as cost effective. And at the medium or high battery storage cost, battery does not appear cost effective. And so this is where that 2 + 2 = 5 example comes into play, where we see a new battery on its own, the most cost optimal battery on its own, showing up with being able to provide $74,000 in net present value. A new PV system on its own, the cost optimal PV system, is able to provide $156,000 in net present value. And this combined solar plus storage system, which has a slightly bigger PV system and slightly smaller battery system than the independent systems, is able to provide around $270,000 in net present value. And this is not considering the value of resilience of this system. This system could provide an additional $6,000 in net present value for every 1 hour outage that occurs on average per year. So if the site is having on average 5 hours of outage per year, this could be $30,000 in net present value additional to the value shown here in resilience value. This value also, I would note, could vary widely based on the timing of outages and what loads are being served. And this value of resilience can be considered as the cost of not having resilience. So what value are you losing by not being able to sustain operations, whether that's revenue, startup costs, or other, salary that's not being utilized towards production. It could also be compared to the cost of alternative backup options, so the cost of a diesel generator and the fuel to run the generator. We also ran the analysis for the future load projections. Very similar trends here. I won't spend as much time on them, but again, we're seeing an approximately 4-hour battery show up as cost effective here. Batteries not showing up as cost effective at the medium or high price points. And the value of a PV plus battery system is it's higher than the sum of the battery only and the PV only systems that are being identified. Again, these results are based on the assumptions that we made, including a 10-year analysis period, an 11% internal rate of return or discount rate. And we are also assuming that the cost of grid electricity is increasing at an average of 3% per year, which might be on the lower end of what we see in real life. If grid electricity increased at a faster rate than what we included in this analysis, the economics of these technologies would increase. So this is a conservative estimate of the value of these technologies. Thank you so much for having me. I didn't go too fast or too slow. And yeah, just really great to be here. And thank you so much to Hong and Tung and everyone at CEIA in Vietnam.
Thank you so much, Kathleen, and we are perfect on time, actually. So thank you for that. I think we still have some time for, I think, 1 or 2 questions left. I think, firstly, that was a wonderful presentation on REOPT, and I think that most of our audience here will find the value and insights into these industrial park case studies that we did with this particular place in Vietnam. I think hopefully with the right pricing point, we can do a pilot project very soon with the same industrial park. I see one question in the Q&A sections. I see that question of Mr. Hai. He said that his company has installed 1,200 megawatt of solar panel system on rooftop, and how much can he estimate in terms of the storage devices? I think my personal question is, can he or someone in Vietnam use REOPT to do so?
Yeah, great question. Yeah, I think it really depends on, I think some of the driving factors of battery cost effectiveness are that capital cost of the technology. So as we saw, we evaluated a wide range of capital costs. And so I think it would be really important to engage with developers and manufacturers and try to hone in on what would the cost of that system be to your site based on, you know, the location and the scale, magnitude, as well as what are your consumption patterns. So when is the electric demand high throughout the day, week and year? When is it lower? And then really critically, how is the utility billing your site? So in this case, there was a time of use component to the utility rate that had approximately 3 times as expensive electricity during on-peak hours as off-peak. So that is a huge potential value stream for battery storage. If that is not there, or there's not a demand charge, battery storage is a little bit more challenging to be cost effective outside of resilience value. But it can, again, it also depends on your clean energy goals. It can be really supportive of renewable generation. Battery can provide, support renewable energy generation on your site, resilience goals, as well as the utility bill cost savings. So those are the 3 value streams that would be important to consider. And to Tung's point, REOPT is available as a publicly available free web tool. I think I might have linked it in the slides. If not, we can share that link, but it is able to be used. We try to make it super user friendly. There are only 3 or 4 inputs that are required. And then there are a bunch of inputs that we have default values for, but you can, customize and make as detailed of analysis or as high level of analysis as you would like. So that could be a good next step to consider if you're evaluating battery storage at your site. And we do have a PV model as well. So you could show that your existing PV system, as well as considering additional, or maybe just considering supplementing your existing PV with battery storage.
Thank you so much, Kathleen, for the answer. I'm really glad that REOPT is open to the public for everyone to use. If you have the time later on, would you be able to share the link to REOPT or light version, whichever version is available, on the chat? I think the audience would much appreciate that. Yeah. Thank you so much. I think surely, I think we are about time for the first presentations. I think just a reminder before we transition to the next speaker, we have, you can continue to put in question into our Q&A box, and we try to answer it either live or in the chat box, or if we have time, I can certainly, some of you can speak up during our panel discussion. But for now, I think we need to move on to the next speaker. And quickly before that, CEIA also have a survey that we seek to get your kind of information and feedbacks on future events or topics that we want us to research and certainly to share on. So really helpful if you can do that. There's no price like a new iPhone or something, but we are very grateful for any of your feedback for sure going forward. So with that, I believe our next speakers will be George and Tarek. So a brief introduction. George Zambori has an extensive career focusing on innovative and sustainable energy solutions, facilitating custom designs of solar-based energy efficient solutions. I think he designed one of the first solar PV powered electric car charging in 2011 in Europe. So that is very impressive for sure. And his broad experience in the renewable energy sector with Unlimited Energy Australia certainly helps different clients in expanding their horizon of solutions when it comes to clean energy. And Tarek, his co-presenter, Tarek Curtinson, is an environmental system engineer with 15 years of experience living and working in Vietnam. We haven't had the chance to have a beer yet, but looking forward to do so the next time we're in Ho Chi Minh. Tarek is the Director General of Amparis. It is a mission-driven enterprise that committed to supporting the government of Vietnam, also the market in general, towards, I think, equitable and clean energy transitions. With his expertise in big data engineering and certainly design to catalyze innovations in the field. So without further ado, George and Tarek are here to share the experience on the BESS market in Asia Pacific and the implication that it has on our local market as well. So please give a round of virtual applause to George and Tarek. Gentlemen, the floor is yours.
Thanks very much, Tung. I'm just going to share my screen here. So let's see, hopefully this works and everybody can see what we are looking at. Yeah, and thanks, Tung, for the nice introduction. It would be great to catch up for a beer when I am next back in Ho Chi Minh City. It's also a pleasure and appreciate the chance to talk to this group. I've been coming to the REBA meeting, the CEIA meetings, I think since the second one in 2017. So I've had a chance to come to a few, and they're fantastic events. Where our presentation is in two parts today. The first part will be George, who's sitting next to me here, and George is going to present about some of the experiences of Unlimited Energy Australia in these BESS solutions for Australia, and I'll then follow up with some thoughts towards an outlook towards Vietnam of how they might be applied in Vietnam. So I'll go to the first slide and pass over to you, George.
Thank you for the invitation, and thank you, Kathleen, to give us a very nice feedback how energy storage is going to be rolled out in Vietnam. I'm trying to give you a short presentation regarding how battery storage actually have been implemented in Australia. As you can see, Unlimited Energy have been working in the renewable energy space in the last 8 years, and we have been focusing on custom design turnkey renewable energy solutions. Our major focus is battery storage, off-grid hybrid solutions, EV charging, and as you know, nowadays, hydrogen is going to play a bigger role. You can see we are not afraid of traveling to remote places. Actually, we love it. So if you look at Christmas Island or Papua New Guinea, where we just deployed the renewable energy system, which actually is running the hospital purely on renewable energy sources in a very remote location. Or if you would hop on the electric cat bus, which is operational this year in Perth, you would experience how EV is actually going to be electrified by batteries. If we go to the next slide, those who haven't seen batteries before, I try to give you a short presentation about batteries as well. We are one of the so-called distributor of the Tesvold energy storage system. Tesvold is actually one of the biggest innovator on the battery energy storage space in Germany. They have invented one of their best BMS, which is battery management system. And I will share you more about how battery technologies actually are evolving. If we go to the next slide, which shows what is the actual selection or capabilities of these battery storages. You can see from the residential scale up to commercial scale and to the megawatt storage space, which is like up to 100 megawatt systems. Some of these units are IP rated for using indoors, some of them are outdoor rated. Most of the battery storages probably require some kind of temperature and dust control, so most of our cases we use the larger system in a containerized version. The next slide shows you the modularity and the flexibility of these systems, so you're actually capable to extend your system any time of the year. You can start with a small system and you just extend it by the time, and you have a real input from your actual consumption on site. Some of the references that we have been doing, they are mostly remote, let's say agricultural, industrial, and commercial entities. Most of them are struggling with so-called upgrade difficulties, like they have a skinny grid, existing skinny grid, and once they would like to extend their operation, they are facing huge difficulties in terms of getting additional power on site. As I mentioned to you, this is one example how electricity can be actually generated on site. If you look at the picture in the middle, you see a large warehouse facility where they installed, I think, 200 kilowatt solar PV. And they thought if they have surplus energy, why not to charge those surplus energy into batteries during the day? As you know, these electric buses are mostly working during the day. So when they return to the depot in the evening, the surplus energy is stored in the batteries, and all these electric buses actually are charged from those surplus solar energy, which we can call load shifting or utilization of renewable energy in a very efficient way. The next one is showing you the roof actually and the distance between the energy storage. It's a simple container, temperature controlled, and they have a connection from the surplus solar. It's an AC coupled system. So it has been running in the last half a year, and we are very pleased with the results. The next one is probably a larger example. This is like a huge solar farm in Germany. As you know, the utility is very keen on having a continuous supply. So if you think of the cloud effects that you have, let's say a 4 megawatt solar system, the big cloud comes and you may end up with, let's say 1 or 2 megawatt injected into the grid. So they are very happy if you can have a buffer, and that energy storage actually can do and produce the difference when the cloud comes. The sizing of these battery units are depending on the actual location. So if you have like Australia, then you can get away with a fairly tiny battery storage system. If you jump from the large scale opportunities to commercial ones, then this is like one of those breweries, which is like a family-owned brewery, but they were pretty remote. They were limited by the energy supply on site. They had a very small 3-phase supply. So instead of upgrading the system and the transformer, they thought, what if we just buy a battery storage with additional solar PV and try to put as much as possible on the roof? The actual outcome that they could become grid parallel, which means the facility can run, let's say, from 7 o'clock up to, let's say, 10 o'clock purely on batteries and solar. And they only have to use the minimum amount of energy during the night when the electricity rate is much cheaper, or they can run a diesel generator as a backup source. I think it's a very competitive system. We have done lots of farms which are actually paying time of use tariffs. And as Kathleen mentioned and in her lecture, that time of use tariff would make sense if you are capable of storing energy and injecting it when you need, or you just have a self-consumption of that extra energy. Just about the mining space, we have been just showing the results of a mining camp, which is a 60-man camp mining camp. This has been implemented 2 years ago, and actually the whole camp is running purely on solar and batteries in the last 2 years with a diesel backup. If you look at how the system was deployed, this is a fully redeployable system, which means if the mine have to move from one location to another, they can easily relocate the whole thing. We have used the surface-mounted solar system, which means there is no penetration into the ground. So it's just keeping the weight through the ballast tray against the wind load. And this system have a so-called modular redeployable energy hub. The energy hub have all the electrical components fully protected from the dust and from the heat differences. By doing so, it provides you a very high efficiency and a very long lifespan. Just if you look at the left corner of the photo, you may see that we have used an east-west facing option. So when we catch the early sun, the actual camp can already generate energy. And surprisingly, with an east-west system, you can reduce the usage of energy storage significantly, at least minimum by an hour. So our studies show that if you use an east-west facing option, you can buy less batteries. Just before this presentation, I had a screenshot of the situation just 2 days ago. And as you can see, the whole camp is running purely on the green one is actually the solar, the orange color showing you the battery storage, and the red one is showing the diesel generator backing up the system when it's needed. As you can see, we are still in the springtime, so it's not even summer, but we have a self-sufficiency quota up to 90%, which is on a yearly average, we were able to save 90% of the diesel on site. So that's a significant so-called decentralized energy storage system, which has proven that it doesn't need maintenance because this actual site is fully remotely controlled, and we haven't had more than an annual maintenance inspection, which was mostly focusing on cleaning the battery modules. I think I have maybe one slide which shows you how the efficiency of energy storage can be improved. As we touched on the east-west facing, I think what's very important that if you choose a battery, you have to choose a very fast charging battery. I thought when I started, I thought it's only for electric cars that you have to have a fast charging battery. But if you think of, let's say you have a cloudy day and you have a short period of time to charge your batteries, of course, fast charging battery can make sense, not to mention when your battery is, let's say 20% discharge or 80% discharge, then you need a very fast charging battery to meet your actual demand. Of course, when you have diesel generators, sometimes they are underloaded and they have high temperatures, so their efficiency rate is losing a lot of efficiency. And if you use that efficiency loss, you can actually recharge your battery twice a day, and that gives you an additional return on investment. I don't go into the details, but the phase change material in this energy hub was used for passive cooling. So instead of using the air conditioners during the night when the sun was not available, we thought we would use the phase change material to absorb the additional heat from the hub. And it actually increased the efficiency of the whole system. And I think we just have a commercial setup, like huge roof space. They put like 100 kilowatt. They wanted to have battery storage for safety for the production line. If the production line stops, they still would like to run it for an additional half an hour. So you can consider this as a UPS system or just a parallel supply. So once your grid is having a blackout, you can still operate your production. And I think this could be useful in Vietnam as well. I think this is more or less I had, and I just hand over to Tarek. And if I was speaking too fast, sorry for the time limit.
Thanks very much, George. And I'm going to maybe speed up my side of the presentation because, well, I think it's an emerging field in Vietnam when we're talking about the outlook for battery energy storage. Very briefly, just about Amperes. So as Tung mentioned, we're a company, we have an office in Vietnam, and we have also an office here in Perth, Western Australia. And we kind of work with, we define our work based on the partners or the clients that we're working with. So we work with governments on planning and policy processes, and have got quite a lot of experience with that in Vietnam and in other countries in the region, drafting, revising laws and regulations, those kinds of things, technical assessments of feasibility of different things for governments. We've worked with communities, so we do projects to improve access to energy and water resources at the community level. And the picture shows one of our projects in Myanmar. That was before the recent coup. We also work with researchers, so we've had some interesting projects to kind of prototype and test new technologies into a market environment. And the picture there shows a project to develop a fully recycled lithium-ion battery for cheaper lithium-ion batteries for use in Myanmar. And we also, probably most of interest to the colleagues who are joining this presentation, we work with companies and in industries, and there we look at ways to decarbonize businesses to improve energy independence and reduce operating costs. And on that technology side, that's where we operate very closely with George and his team at Unlimited Energy. So I'm going to I'll shorten my side of things probably to about 6 minutes, Tung. I hope that's okay. As I said, I've been joining the CEIA meetings since the first or the second one in 2017. And I've always come with a lens of trying to look for that entry point for battery storage and when would be the right time to introduce battery storage. And I see this as sort of a problem similar to the kind of the glass half empty or glass half full. To be frank, up until today, it's always been a sort of a glass half empty, more pessimistic scenario for battery storage in Vietnam. And that's, I think, Kathleen touched on a few of those economic reasons for that in her presentation at the beginning. And I guess what I'm going to try and think about here is what is there in the coming future that might turn this from a sort of a bleak, pessimistic outlook into a more positive opportunity for batteries as a glass half full situation. I won't talk much about, I'll skip a little bit about the Vietnam power sector, but the main point to make here is that it's changing rapidly. If you look at any kind of indicator or metric, and I show you 4 across the top there for energy access, peak load, energy production, private sector investment, everything follows an exponential curve. So it's something that's changing really dramatically. And that in itself means we as the kind of the consumers of energy and the generators of energy need to be kind of flexible and responsive. The key thing the key statistic that we need to think about from our perspective is that the solar story in Vietnam is a mixed one. So yes, we can say there's been some immense success with the feed-in tariff, and we have about 24% of total installed capacity is solar PV. That's both rooftop and utility scale. But actually, when we look at production, electricity production that's being used on the grid, it's only about 5%. So there's a big difference there in terms of what is contributing to the energy supply relative to the capacity that's installed. And there are some reasons for that, which we can get into in a second. If we look into the PDP, there's obviously a long and not yet finished discussion about the PDP-8 process in Vietnam, or close to finish, let's say. The key thing to mention here is that the government of Vietnam is looking at power generation in 2 steps. And you'll see that in that first step, and I've circled here the rooftop solar and the solar PV, there is no plan to add any more solar into the Vietnamese system in the next 10 years. So the next 10 years is really about gas, continued reliance on coal, and then there's also some onshore wind as well. And after that, there's a plan to have more solar and more renewables in general added to the system. So we're operating in a policy environment where we don't expect to see much support for solar, at least in the plan as it stands at the moment, coming from government. What would that mean for us? Well, if we look at rooftop solar as a sort of a case study in this, we can see some really impressive results here. We've had rooftop solar capacity of more than 9 gigawatts installed in 2020. That's based on this feed-in tariff, as everybody probably in this room is familiar with. And then after the end of that feed-in tariff, in the last 12 months, we've had maybe 400 megawatts of capacity. So without the kind of that policy incentive, the deployment of rooftop solar systems has dropped dramatically, several orders of magnitude, let's say, since then. So, but from our perspective, what we see is that this 400 megawatts of capacity that's installed last year is the most interesting for us, because that means that it's not being developed for export to the grid as a kind of an economic revenue generating activity, but it's more about self-consumption, meeting like corporate social responsibility targets. And we think in that space there is, if we contextualize batteries in that space, there's opportunity there already starting to emerge. The other aspect, of course, for rooftop solar, like the utility scale solar, we've experienced significant curtailment in recent times. And so the estimate from last year is about 1.3 billion terawatt hours of solar generation, both rooftop and utility, has been curtailed to some degree. The curtailment procedure is focusing on those larger solar generators, so utility scale farms first, but then also the larger rooftop solar systems that we see in the system, the ones that are close to a megawatt peak in capacity. And the curtailment is usually in that middle of the day period from 10 to 2:30. And of course, more of the curtailment is occurring in the south, where more of the capacity is installed. And in some cases, we've seen that EVN is setting a zero export limit for the rooftop solar systems. So future prospects before 2021, rooftop solar was in a boom period because of this economic benefits. Post 2021, we've got to think about the value proposition for rooftop solar in a slightly different way. It's about self-consumption, meeting site consumption needs. It's about net zero pledges of companies. It's about energy security and reliance, which I think also, or resilience, as Kathleen mentioned. And it's about savings, operational cost savings. And we start to see some signs in the media that this has got some real traction in Vietnam. And I just put here as the kind of the big ticket example of the Lego factory, which is being slated for development in the country. The other aspect of this, which if you can see from the text on the right there, is that Vietnam, as a sort of an export-oriented economy, is exposed to kind of the global consumer market and the pressures that are on the global consumer market for how things are produced, especially the carbon footprint of production. So multinational corporations working in Vietnam are under, and we'll talk about these in a second, some pressure to, or some interest to, incentive to decarbonize their operations. I won't talk too much about the COP NDC process in Vietnam, but the main point to make here is that we've got a net zero target, but if we look again at the short term, there's a much more modest commitment to decarbonization on the government side. Mentioned very quickly here about the carbon markets in Vietnam. So we will be having an emissions trading scheme arriving in Vietnam as slated for 2027. And that's sort of mandated in the new environmental law that was passed. It's going to apply to specific kinds of facilities, so thermal power plants, freight and cargo transport, commercial buildings, solid waste management facilities, all of those kinds of facilities that are sort of large scale, producing more than 3,000 tons of carbon dioxide a year. They'll be asked to make a baseline, and then from that baseline to set emissions targets and to meet those targets. There are, of course, other kinds of carbon markets, and I won't go through them, but they're actually quite extensively have been employed in Vietnam. So CDM is one that's sort of now finished, but there was quite a few CDM projects in Vietnam in its time. The JCM is a joint credit mechanism. There's 14 projects now, gold standard, verified carbon standard, CERs and IREX. So in total, 100, 200 projects that are applying, that are getting benefits from a voluntary carbon market to decarbonize their sector or their business. And the other part that's, I think, we're talking on these incentives for multinationals or companies that are working in the trade, exporting goods produced in Vietnam outside. Europe is a pretty big market for a lot of these companies, and we see that there's in the order of $1 billion US dollars per year of trade to the EU, and the EU will be introducing this carbon border adjustment mechanism, which is essentially a kind of carbon tax, and that tax will be applied to take into account the cost of carbon emissions, which is not really taken into account at the moment in how we price our goods. Important point to mention is that actually the carbon tax, this carbon abatement mechanism, the tax can be collected in the EU or in Vietnam, and obviously there's a big difference there from a government perspective if they were to incentivize companies to if it was collected in Vietnam, it could be used to support low carbon transition in companies. So I've got two slides left. So we talked about battery energy storage. The point to make here is that there are different kinds of battery energy storage, and they offer different types of benefits. And I think one of the questions raised was, well, what's the sort of the size that we need? Well, it depends on what kind of benefit you're trying to achieve, and also on what kind of batteries and what kind of capacities or capabilities, as George mentioned, your battery has. So fast charging, for example, offers different kinds of benefits to one battery that takes longer to charge. Put simply, I just want to show you this figure on the right here, so you can see I've taken a load profile for southern Vietnam from 2016. So this is for the whole of the southern part of the Vietnamese grid. You can see it's got two peaks at the beginning and the end of the day. Probably if you've got a factory, your load profile looks a little bit flatter than this. It's not, jumping up and down as you can see in the in this figure here. But that's just sort of a generic load profile. At your site, if you've got a rooftop solar system, you'd be aware that you're generating in the middle of the day more than what you're consuming. And then there are other parts of the day when, of course, at nighttime, when you're not generating any solar and you're relying on the grid. So underneath this curve here, this is all at the moment relying on the grid, and over here as well. And this is all solar's providing some support. And of course, every project will have a different different shape to these curves, but that's the basic principle. For a kind of a good example of how to use the battery energy storage is that you would take all the excess solar, so the dark pink area that's more than what you're consuming on site, and instead of exporting that to the grid, or if you've got the FIT, or if you don't have the FIT, you can't export it to the grid, it's being wasted. You would then use that to cover, let's say, some of your load in the peak period time. And you can choose when you dispatch it, of course. So you cover in the peak period time and try and reduce the cost of buying electricity from the grid at that time. Just a couple of points on conclusion. I think on the technology side, often people say battery is sort of an emerging or a new technology. It's not. It's proven, it's long-term, it can offer quite a variety, a range of benefits. On the policy side, this is really changing in Vietnam, and we should not be expecting proactive or supportive policies unless we advocate for them again and kind of and make suggestions about what could work well to bring BESS. It is a capital intensive exercise putting in batteries. And I think, as we saw from Kathleen's presentation, often the economics it may not be entirely suitable for Vietnam, and that's in part because the end user tariffs in Vietnam are very low, amongst the lowest in Southeast Asia. So I would say that at this stage in the evolution in Vietnam, the economics alone may not justify a BESS system for your rooftop solar system. But of course, we have these other drivers of carbon, greenhouse gas emissions reductions, exports to countries which are imposing taxes on carbon, and then getting also potential benefits from other kinds of markets like the voluntary carbon markets. Okay, I think that's the last slide. Yeah, thank you, Tung. I think that's all from us here.
Thank you so much, George and Tarek, for the wonderful kind of sneak peek and overview of a more developed battery storage market in Australia. I think the kind of implication it has on Vietnam and our potential for this market as well. In the interest of time, I think I need to modify our structure a little bit and bring out some of the more burning questions that we have from the audience from the Q&A at the last one. So I think George and Tarek, coming from a more developed market, and certainly Tarek with your kind of environmental background, there are questions from the audience and concerns with regards to the environmental, health and safety aspect of these battery storage projects. For example, how much land does it take up during the development process? How do you manage the EHS kind of aspects throughout the life cycle of batteries? And I think specifically at the very end, how do you make use of the waste that come from those kind of projects?
Yeah, they're important points. George, do you want to have a...
Yeah, so Tesvolt, as a German manufacturer, have a recycling policy. So actually, they take the battery back once it's reaching its lifespan. Actually, it's warranted for manufacturer warranty for 10 years, but it doesn't mean you have to throw the battery away, because actually that's 70% of so-called end-of-life capacity. So you can still use the battery for another 10 years. And we can experience that even in Australia, lithium batteries recycling is starting to get a momentum. As you know, when it gets the right scale, I'm sure in a few years' time, this will be like normal procedure. So that's just touched on the battery recycling itself.
And then on the health and safety side of things, I think that's an important consideration when you choose your batteries. So different batteries have different kind of thermal environments that they can operate in. So, environmental conditions, and they also have different safety. So, often, George showed some projects that are installed in remote locations that are sort of, 1,500 kilometers from the nearest city. So they're in the middle of the desert. Hot environment, gets up to 50 plus degrees. So it's something that you have to you pick a technology that can match that environment as well. So it's very important to consider that as you choose your batteries.
Thank you, George and Tarek, for the wonderful insights. I think totally agree on that. I hope that the recycling market in Vietnam as well will catch up with all the, solar panels and potential waste from the batteries in the coming years. Because I think in terms of the policy side, we hoped to have the kind of at least similar or a bit more detailed guidance when it comes from government on recycling of the solar panels and then eventually for battery storage. So thank you for that, for sure.
Chung, just one last point on that. I think it's important to kind of we obviously most batteries that you're going to install will last for, let's say, a period of 10 years minimum before they have to consider replacement. So, at this stage, I think and then of course, as the more batteries are deployed, the potential for recycling industry increases because you've got more of a market for that kind of thing. So these kinds of, I think we should always be careful to frame these kinds of discussions about recycling and so on as not as a barrier to deploying new systems or new ideas. It should be, we should get on to the task of doing these things and then plan for it, but use the 10 years we've got to kind of grow that industry. Right now, I think the key thing is we focus on the real pollution that we are facing, which is the CO2 emissions, and cutting out as much as we can.
Yes, I love that. That's half-full kind of approach to that issue, Tarek. So certainly keep that in mind for sure. So thank you once again, George and Tarek, for your wonderful introduction to the kind of market potentials in Asia Pacific and eventually Vietnam. We have heard from multiple speakers about the kind of implications for the market and kind of feasibility level for this, but I think it's worth now to move on to an actual kind of projects in Vietnam that has been, I'm happy to announce that has been installed and under operations in the past month. With that, it is now my honor to introduce Mr. Nguyen Nguyen, the country manager of Bastiani Engineering Company. Personally, as bilateral partners, we have had the pleasure of working with Bastiani for the past year or so on this. I think among the first pilot CNI battery storage projects in Vietnam. And the experience has been nothing short of exemplary, though abides for some minor hiccups in terms of COVID lockdown and global supply chain disruptions. It was all good aside from those. And a little bit of introduction to Bastiani Engineering Company, or BEC. They are, I think, one of the leading 20 EPC suppliers in the solar rooftop industry in Vietnam. They have had experience with a lot of extensive list of projects across the countries, and certainly it is a spin-off company from the Bastiani overall group company for sure. So without further ado, please give a round of virtual applause to Mr. Ngan and his presentation on the pilot battery storage in Vietnam. Mr. Ngan, the floor is yours.
Okay, thank you, Mr. Tung, for your introduction. And also, I thank you for your participating today. I'm Ngan, and I'm on behalf for Bastiani for presenting today. Actually, maybe all you know that the BESS, I mean the battery system, is not popular in Vietnam, and we're very happy, we were very lucky and honored to receive the investment from the users. Before starting sharing something about our experience and our pilot projects about BESS in Vietnam, I just overview something about my company. Yes, but BEC, my company is a Bastiani engineering company, and we were founded in Italy in 1950. And Bastiani company specializing in renewable energy under the Bastiani group, and our CEO is Italian. Together with our partner, we have a strong foundation to provide optimal financial solution and to minimize your investment, to offer long-term energy supply contract. In past 4 times, we have actually we have 12 years of experience in solar power, but which appears in Vietnam about around 4 years, start 2018, and the total capacity we did in renewable in Vietnam is around more than 17 megawatt peak, with 70 projects we did in Vietnam. You can see you can see some projects, some typical projects we did in Vietnam. Yeah, and most of our project is we did on the roof of the API enterprise. Yes, just something about my company. Okay, now I will start introduce something about the BESS principle. Actually, the BESS is integrated with in parallel with the electrical system you can see on the diagram, and the battery system will be programmed to charge during peak time where entry is low and discharge during peak time. I'm sorry, charge is low time. Through peak charging and peak discharge, factory will save some costs from purchasing electricity system. Yeah. Our pilot BESS system, we did this project under USAID Vietnam Energy Security as Innovation Challenger Fund. And maybe on of us knew that USAID is a United States agency for international development and had established in November 1961. Yeah, about the pilot project battery system Vietnam, we want to show that the demonstration site can reliably use energy from BESS during the peak hour and therefore downstream on the local electricity. That's why we want to demonstrate that BES can provide a reliable emergency backup for essential service. That's why it will reduce on-site electricity demand and associated costs during peak hour for CNI electricity customer. And after finishing project, based on our experience, we can share the lesson and data from the pilot project, because maybe it's not popular in Vietnam, and just we need to learn more, to have more knowledge and more experience when we did the project. Our pilot project did at the Sonian factory, and the Sonian is like in international company established in Danish and founded in 1974. It is a manufacturer of components for audio and visual equipment, and you can see maybe many of us use the product of the company. I mean, because it is an international company, so they want to have the high standards. And once we implement the project in this company, we need to have the high. You need to supply the high quality and high safety when construction. The project battery system use production design and manufactured by Actionable battery system. At the moment, they have many suppliers, many companies supply the BESS technology, but we choose SYL, a unit operation corporation in our project. And the BESS system has a capacity of 100 kilowatt, a storage capacity around 224 kilowatt hour. Here is some overview about this project. You can see on the screen. So in detail, CBS use lithium technology, and which is a battery that can be recharged and recharged many times. The low peak, it can recharge around 96%. And lithium is popular for its advantage such as a high energy density, large capacity, or small battery size, and less that recharge and keep energy for a long time. And more than that, it's very environment friendly, and each type of battery that's widely used in electronic device today. Okay, here is statistic of the graph as this, but the capacity decrease year by year. As a warranty period is 10 years for this product, and the life cycle of this battery is 20 years or over 30 years if we have the operation and maintenance well. In addition, the system is provided with a modern monitoring system, and especially upset system is battery management system with 3 layers of control and 3 layers of active protection. It will be proven to improve battery life or overall system efficiency. And this battery life is predictable, will last more than 10 years. You can see that. And here is some advanced feature of BES should provide from as well are. You can see the safety, even low fire hazard, higher safety. On-up it will adapt on-up standard from UL, UN, or IEC. Available of this system is more than 97 per year, and will have full protection function. It's a short circuit overcharge, overload, or high temperature, or other safety feature. Because on a component of this system made from aluminum, so they has the corrosion protect function, and the most important is the design. It will have the advanced thermal design. Yeah. After completing the project, we just want to share some experience from the pilot project. Actually, this is a calendar of approaching new technology, and this is a new type of technology even in the world. Therefore, during the implement process, BEC always carefully study its instruction from the manufacturer, consult in the consulting unit to avoid error in the installation process. By the way, I'm honestly thank you for company and SWL team support us through the constructing. During the implementation process, we always keep the communication with the factory units, instruct the factory unit on how to operate the technical requirement, and always follow up with both manufacturer at the same time and Sonian factory, so that the installation takes place according to technical requirement of both parties. You know that safety is always a more important factor, and the personnel in the implementation process must always be fully assured of labor protection equipment, and construction job must always have the safe procedure go with. In addition to installation and operation, BEC will also coordinate training to factory technician on troubleshooting method when problem arise. Troubleshooting instructions are always posted in the area where the BESS is located to ensure that technician follows the correct procedure. And BEC will implement periodic inspection after installation to ensure the system is always operating at its best and to prevent risk from the occurring. Internet, I just have some potential of the BEC project in Vietnam, and maybe Mr. Charles and Rail share before. Here is a chart, renewable target in 2020, 2025, and 2030. You can see on the in your chart, and as a share of the renewable energy sources increase Vietnam, renewable energy sources mainly depend on natural factor. So unstable power generation will affect and pressure our Vietnamese power grid. In order to stabilize that stabilizing impact to solar and wind and energy sources on the grid system, energy storage systems are also playing an increasingly important role. And Vietnam Electricity Group is also working with partner to put BESS, I mean the battery system, into practice. And battery system will be expected to become a popular model in Vietnam in the future, to be applied integrated in the factory, in the CNI, factories that have installed solar system and solar farm system in the future. And thank you for your listening.
Thank you so much, Nguyen, for your sharing of our wonderful projects. And certainly, I hope that as the system operates a little bit more, we have more data and reports to share with the wider market in the upcoming weeks and months. As one of our objective for this project is to pilot and then share the knowledge that we have attained to anyone who is interested in the market. So excited for that, and thank you for your presentation. Well, we have 4 minutes left until the end of the event. I think we are supposed to have a panel discussion now, but I think there's not much time for that. So I'd like to invite all the speakers that we have had so far for 1 or 2 parting kind of questions and conclusions before we can close the events and leave people to their day. So going back to, I think, Kathleen, for sure, as you open our presentations, our series of presentations for today, I think what is, you have worked on the feasibility studies on the re-op tools. I think my parting question to you is, what do you think is among the first kind of factor that needs to be addressed for an industrial park or even the factory to implement battery storage in Vietnam, and one of the first 1 or 2 for us to go forward and scale this up?
Yeah, I would say just considering the potential value streams of the battery at that location, in particular, looking at that utility rate to consider any energy arbitrage or demand charge peak shaving opportunities. I think there are probably a bunch of, I'm coming at it from the techno-economic modeling side of things, but then there are also the kind of logistical and engineering components as well about interconnection policies and those kind of pieces that I don't have as much expertise on, but would be very important to consider in making that type of decision.
Thank you so much for sharing. And I do agree with the kind of view on logistic challenges, because I'm sure that I think Nguyen from BEC would know of the kind of logistic challenge that we have had with getting batteries during the past months or so with the global supply chain disruptions and a lot of this lockdown issue in China, which I think most of the battery system nowadays, at least in the regions, originates from. So thank you for sharing, Kathleen. And my parting question to Tarek is that I think certainly has more to do with the policy side as you're in Vietnam. What do you think is the first kind of guidance, which area of guidance you think is most relevant for the BESS market, whether it is, I think, permitting, or is it technical guidance on the configuration of the batteries, or environmental and safety aspect?
Yeah, it's a really good question. I think what I learned a lot actually from listening to some of the other presentations here as well. And we can see that because it's such a new industry for Vietnam, or a new sector for Vietnam, there's so many unknowns from this, like connections, how to kind of link in with the time of use tariff, how to what can be exported, what can't be exported, what size system suits, how does it connect with rooftop solar, or you have BESS without the rooftop solar and just the battery system itself. So I think actually the very first thing that should be done from a policy perspective is more of the piloting that you guys have already started. I think there should be sort of support for, I mean, this is often the case in policy. You'll have kind of a pilot phase or a pilot program. You iron out all of those issues. You come up with solutions for all of those, technical and financial issues that suit the Vietnam context. So I would say sort of subsidy type support for structured small scale, to kind of target piloting. This is the key thing to get going now, so that we can understand what are the right solutions for Vietnam. And then from that, you can then look into what are the kind of the regulatory changes you need to follow from that.
definitely agree with the chain of thoughts there, and I certainly hope, like I mentioned before, we hope to, after some time of operating this system, we really hope to document our process and our journey throughout the past year. I think, to be very honest, it was quite difficult in some aspect of that, and we'd like to share that to the market, and hopefully we can do eventually some policy engagement on that side of things. So hope that we can do so soon and share it with you guys for sure. All right, I think we are right at the time. So firstly, thank you to all the panelists and the speakers for joining us today. We have had wonderful insights from the different projects and market implications for battery storage in Vietnam. We hope that this is only the first of perhaps a series of events and topics on energy storage, and certainly hope that the market will develop in the near future with tools from like Reopt, from Kathleen, and certainly with developers and I think non-profit organizations like BESS and Tempest engaging in this conversation, having all the people present here for that. So thank you once again for joining us today. We do have the survey, so if you have time, feel free to fill that out so that we know what is the best topic for CEIA to move ahead in the upcoming months or year. So thank you, have a nice day, and happy Vietnamese Women's Day.